Hello, Year 4. How are you all? I'm Miss Marwa Adel, your science teacher, and today we are going to the magnets. So, are you ready? Let's start. First, we have to know that the magnet is a piece of metal made of iron or nickel, so it has a special property, can attract some materials to it. Okay, so some materials can stick to the magnet because it has power, and this is it's called force or magnetic force. Okay, so each magnet has two terminals, mainly with red and blue color, and even it's not colored. So it has two terminal. The first one is S is referred to the South Pole, and N is referred to the North Pole. Okay, and magnets come in all shapes and size: horseshoe magnets, bar magnets, ring magnets, ball-ended cylindrical magnets, and each magnet from these has two terminals, south and north poles. So here I have two magnets. What happened here? They are unlike poles, right? The north and south. N for north and S for south. They are unlike, right? They doesn't look like each other. So they attract together or stick together, and we can call it attraction force. There is a force between them. There is a pulling force. They are sticking together and they are called attraction. The second thing here, I have another two magnets, but I will put the N north to the beside the N. They are not attracted together. There is another force. It's called repulsive or repel. So the like poles, the N and N or S south and south, they cannot stick to each other. This is what cannot stick to each other, cannot attract to each other. This is repels. Okay, this is repel. So some magnet materials can be attracted to the magnets, and they are called the magnetic materials, like this nail, the fork, and the paper clips. They are made from steel or iron. So some materials cannot be attracted by the magnets, like the plastic, the aluminium, and the copper wires, okay, because it's made of copper, and the wood. They are called non-magnetic material. They cannot be attracted to the magnets. So if there is a magnetic force between the magnets, look to the two magnets, the N and the S, and there is iron filings. Okay, this is a very thin iron. Okay, it's like powder. Okay, so this is a magnetic force called the magnetic field. Look to the line. So to understand this more, we have to put a magnet near the iron filings. Here this is like a glass, and I put the iron filing inside it, and this is the magnet. Look at the diagram. The iron filings will line up, make a lines along the around the magnet, but they are sticking strongest where at the poles, the north and the south. They sticking more at the north and at the south, but in the middle they are weak. So the magnet is strongest at the poles. Okay, so the magnets are strongest at the pole. Watch it again here. The iron filing will line up. Look. Okay, so they are line up to the north and the south. This is the power is the strongest where near the north and near the south, but in the middle they are weak. So this is the earth. Okay, so you know that the earth is act as a giant magnet. Why? Because inside at the center of the earth there is a liquid core. Look to the yellow. The inner core, they are made from molten metals like the irons. So, and guess what? Who's made from iron? The magnets. So, the inside the earth, the center of the earth creates a magnetic pulling force at each end. Okay, it's like that the earth is look like a giant magnet. Here, this is the earth. So, and I have here the inside the earth, it's act as a giant magnet. So the south end of the bar magnet is attracted to the North Pole. We know the earth, there is North Pole and South Pole, okay? So the south end is attracted to the North Pole and the north end is attracted to the South Pole. And this is the attraction, the magnetic force of the earth. So if I put here a magnet, it always will point to the north south direction. It's a freely suspended magnet. I'm going to hang it with a string. Okay, so I'm going to look to it. It will point always to the north and south direction because the earth has a north and south poles, and the magnets, it's look like a giant magnet. Excellent. So we're going to use it as an application, the compass. The compass here is a magnet that can turn freely, so it always point to the north and south direction. Because of what? Because of the earth is look like a giant magnet, so we are going to turn always to the north and south direction. Another application we can use it because of the magnetic force. There is here a very important metal, it's called aluminium. Okay, like this aluminium cans. So the aluminium is a light metal, easy to shape, rust proof, it's very impressive, it's very expensive and difficult to make from the raw materials. It's difficult and expensive to do it, okay? So they discovered that it's non-magnetic materials. Okay, so it's non-magnetic metal. So what I'm going to do, it's expensive to make it, so I'm going to recycle it. Yes, excellent. So but how? Here I'm going to use a magnet to sort the metals, and the metals here I'm going to use separate the aluminium and the steel cans. So if I have aluminium cans and the steel cans, I'm going to put it here. So the magnetic ruler with the red one, it will attract the steel cans. Okay, this is a magnetic materials in the red one. Okay, and the leave the aluminium cans behind, the non-magnetic in the blue one. So I'm going to separate it, the magnetic and non-magnetic like the aluminium. So I'm going to use the magnet to sort the materials, right? And this is very important. The recycling centers use the magnet to separate the aluminium and the steel cans because the aluminium is so expensive to make it from the raw materials. So this is the end of the topic. Thank you guys.